know on Monday, everybody knows that I'm going to ask you what you did over the weekend. Fun, right? Right. So if you did something fun, you go to a good restaurant somewhere, or right? I want to hear about it. Okay, tell me about it. It'll be fun. I'm going out with some friends tonight to a. I'll tell you guys on Monday where. I'm not telling anybody tonight. Secret location. Even the people we're taking, we're going out with some friends. They don't even know where we're going. But it's in the boondocks. It's way out of town. And a little teeny town has a restaurant there that my wife and I like. So we kidnap people and go out there. That's what old people do on Friday night, right? The big thing is to go out and eat. Yeah, the place with the good French fries, right? That's it. Okay. Here we go. Oh, let's get down to where we left off. Here we go, right here. We had left off with compound function, composite functions. Composite functions are a function of a function. So we take the result of one function, and it becomes the input into another function, right? And we computed a couple of these. How about this one? How about this? For f of x equals that, g of x equals that absolute value of x plus 2, find these two. G of f of x and f of g of x. Right? So, what's this going to be? This is f of, I'm going to do g of x. Right? That means f of absolute value x plus 2 equals what? Everywhere there's an x in the function f, you're going to put absolute value of x plus 2. Right? So that's going to be 3 divided by 1 minus absolute value of x plus 2. And that's your final answer. Everywhere there's an x in the f function, you put what g equals. All right? How about the other way around? G of f of x?
Well, it should be minus.
Oh, what did I do?
It should be minus
Negative.
3. Yeah. Negative.
Oh, yeah.
We don't solve that. We just leave it like that.
There's nothing to solve. You could only solve something if this were like equal to 12 or something. Then you solve it, right? Solve means find the solutions, right? So I'm just trying to get you to understand what a composite function is. And you're right. No. That's it. You're just finding the composite function. How about this one? I know what you're thinking. You're thinking, doggone, some things take 2 sheets of paper and you do that in 1 sentence, right? I get it. And I'm glad some of you are finding it easy. All right. How about this one? This is going to be g of f of x equals g of what f of x equals. There you go.
That's it.
Nope. We got one more. Maybe 2. This is going to be g is this absolute value right. I'll bet if you saw this in a book somewhere, this would be fine for me, right? But you see that negative sign? Some people would do this. You don't have to do it. You can flip the order of the bottom and get rid of that negative. 3 up there. But what's in that? What I boxed in is fine. Not a lot, not a ton of stuff to do here. I see. I totally see that. All right. Okay. Expressing a function as a composite of two other functions. There is more than one correct answer for this one. Okay. And any way you would do it is fine. All right. Any way you do it is fine. But one way to do this is say, okay, so I want to make this a composite of two other functions. So I'm going to do g of x and h of x. And let's see. Let's make h of x, g of x will, h of x, make it what we're plugging in. Let's make this one maybe 2 minus x for that inside part. And this one is 2 over x squared. So f of x equals h plugged into g. And to use the notation we did before, okay. Because if you plug the 2 minus x in to the x squared, yes, sometimes that street gets really loud. I apologize for that. One thing I haven't heard in a couple of years is an accident. This time in the afternoon, some people, the first kids at the high school start letting out, and they come down the street because the high school is like a mile up the road, right? Or not even, maybe half mile up the road. And they come through and they don't look at the stop sign. And it used to be a couple times a year you'd hear, we don't get out, everybody looks out the window. Okay. Fortunately, that hasn't happened in a few years. So that's good. Anyway, so here's that's your answer. You find that, yes, sir.
So here you have to like basically separate that one function into two.
Yeah. Yeah. Now I can think of some other ones. Another possibility would be this. Another one, a non-core solution. No extra charge. Okay, you could do g of x and h of x. And how about if you did this one just to be 2 over x, and this one to be 2 minus x squared. So you put the squared part on this here. Okay. And you could probably think of other ones. You could probably find some other ones.
As long as they combine.
As long as they combine, I'm cool. Yep. Yep. And don't worry about having what's on my answer key. And by the way, if there are more than one way, there's more than one way of expressing a solution, I'll take care of that. In other words, if you express it right, and I didn't say how to express it or something, which usually I don't, you need to simplify them. Right? That much you need to do is always simplify. Okay. All right. Identity function. I of x equals x. Now, I've never seen that notation in my life. All right. But I of x equals x is called the identity function. Where I'm from, this is called y equals x. Right? And it looks like this. Slope 1 through the origin, you might see it as f of x equals x. Right? That's it. That's it. I know what you're thinking. Mr. Miller, this is getting, no, you're worrying me now. No, this chapter gets more intense. All right. Now, we had, as you remember, we had a couple of homeworks I said do after the test, right? And I think those are like Monday or maybe some today. Okay. So hopefully you did not put the class totally on hold to just do study for the test. All right, but anyway, these we'll make them do. They're due on Monday.
And they to improve the mark for the.
Oh yes, yes, that's very important. Yes, thank you. Let's see. Today is Friday. I always allow 2 class periods. So Wednesday. Wednesday at 4 o'clock will be your last time to have completed your corrections. All right. Now I have a meeting, I think, on Wednesday. And so you're going to have to come by before 3 o'clock, but you can work on them during that extra hour if you want, right? Up to 4 o'clock. If you want, like I said, I'll bring the tests. If anybody tells me ahead of time, I'll bring the test to Spark session on Monday night, right? And we can go over some problems and you make your corrections then. Hopefully you guys don't have that practice so late for a lot longer. You're going to have it this Monday though, right? Probably. Yeah, that really stinks. They say in Italian, puzza. Right? Inverse functions. These get a little spicier. An inverse function is a function that undoes what another function does. So I have a function that adds 1 to any number. Well, the inverse function would be a function that subtracts 1 from every number. It undoes what the first one did. They don't say that simple, okay? But like find f of g of x for these 2 functions. All right? So f of g of x is f of g of x. I'm putting in more steps than you probably need to. But I hope for those who are rusty at this, that this will provide a little refresher. That's going to be f of whatever g is. Goes in there. Right? So wherever there's a x in the f function, I'm going to put 5 plus 3x all divided by x. So now I'm plugging this green thing in there. Right? So I'm going to have a 5 on top. Plugs in for x. And your big mean teacher makes you simplify. How do you simplify that buzzer? Well, got some ideas? I'd get rid of that x.
You put the x with the 5.
Now that's interesting. You can't, okay. There's a way to do that, but it's not probably how you're thinking. Don't write this down. This does not equal 5x you would have to include this 3 here. Okay? In other words, you'd have to combine these first. Then you can put the x, you could do something like that.
So you can put like.
You're close. You're not far from the kingdom of God. Okay?
Can you cancel the x's?
Oh, that's a big one. The answer is no. This, And here, let me show you why you can't do that. All right? Let's just use some simple numbers. 2 plus 3 over 3. Right? If I cancel the 3's, that gives me 2 over 1 equals 2. But what it should be is So you see, you come out with something different. Here's the rule. You can only cancel factors. Now, factors are things that are multiplied. So if the whole top is multiplied by 3 and the whole bottom is multiplied by 3, you can cancel the 3's. But here, the whole top is not multiplied by 3. You have a 3 there, but not right there. Now, if you wanted to be technical, one thing you could do, 2 plus 3 over 3, I could factor a 3 off the top. If I wanted to, 3 times what gives you 2 plus 3? Well, 3 times a 1 here, 3 times 1 gives you 3. And 3 times what gives you 2? Before you strain your brain too hard, that's 2/3. And so there, 3's a factor there and a factor there. You can cancel 3's. And so this will equal 2/3 plus 1. 1 is 3/3, right? And that's 5/3. That's the same thing you got that way. So if you 3's this way are a factor, and so it comes out the same. Yeah. Now this one here, what do you do? I can think of shorter ways, but sometimes the shortest way is not the intuitive way. It's not something that someone watching it will learn from. So this isn't about doing the magic up here. It's about giving students a tool.
Times about negative.
No? Here. When you see this, hopefully it'll make sense. We're going to multiply by 1.
Oh, yeah.
X over x. Why did I pick x? Because x times this green thing cancels the denominator. But I have to distribute that x over both of these terms. All right? So the reason I picked the x is because of this x here. That's why I picked the x. But I have to distribute that x times the first term in green, and then x times the -3. And then, of course, x times 5 on top. So that is going to look like what? Top, 5x.
That was easy.
The bottom, x times the green stuff, is 5 plus 3x. The x is canceled. You okay there, Trevor? Right. Stop me.
Basically, it's like you put the parentheses x in front.
Yeah. And he's saying it's basically you're treating this like this. And now you're going to distribute the x to the -3. Yeah. Then sound effects mandatory for guys. Right? Most girls wouldn't be caught dead with such primitive communication. And I don't blame them. That's why girls have more class usually. Right, Cammie? Yeah. She's going, no comment. I'm pleading the fifth. This is 5x over x. Oh, no, 5x over 5. Enough of that. No fun in algebra class. Cancel the 5s. That gives you x. I'm going to put a little thing around this too. So what just happened? All of that just to get a lonely x back. What this says is, remember how I started this slide? An inverse function? An inverse function is a function that undoes what another function does. So whatever 5 plus 3x, whatever g does to a function, or does to a number, So G is going to do something to a number. It's going to send it to another number. F will take the other number and send it back where it started from. An example I like to use is your name and a social security number. Right? Your name and a social security number. You can look up on a computer so-and-so's name, and in many cases, in your record, there's your social security number, right? So look, a name goes to one social security number. A social security number should go to only one name, unless somebody's been shopping on the internet, right? You know what I mean? So if you look up somebody's social security number, there's the name. It can go back the other direction. It's a one-to-one correspondence. In fact, your social security number is pretty much a substitute for your identity, which is why we don't give out social security numbers anymore, right? Back in the day, they did, by the way. Oh, yeah. Oh, yeah. When I was in college, quick story. When I was in college at the University of Florida, 35,000 students on campus, right? 35,000, one campus, right? Yeah, they would. Well, now it's 55. Okay. What they would do is they'd say, hey, the police department. I'm not kidding. The big campuses have their own police department, and they're real cops. Okay. And they would say, okay, you can bring your valuables by to the police department, and they would etch your social security number into your back then your calculator or your bicycle or whatever. So I had a bicycle with my social security number on the rim of the bicycle and all the parts of the bicycle. So if your bike got stolen, they found it, they could look you up and get your bike back. That was the idea, right? Back then, if I had your social security number, it meant absolutely nothing. I couldn't do anything with it. Right? Now, I can go on the internet and become you. Right? So that's the one-for-one function. Now, down here, note, the inverse of a function f of x is denoted or called, written, f with that little -1 of x. That -1 is not an exponent. It kind of looks like one, doesn't it? But it's not. I didn't invent this. I did not invent this notation. So this does not equal f of x to the -1. Does not equal that. Which this would equal 1 over f of x. So those are different. So get used to that notation, right? It's pretty standard, actually, across textbooks and so forth. So what we've had here is if, in our last example, if you took x and stuck it into one function, it produces some number, f of x. It maps it to another number, sends it to another number. Then if you take that number, stick it into the inverse, it undoes everything the first function did and gives you your original x back. All right? Down here, we have a little example. This is a little example. For these two functions, what happens to x equals 7? Okay? So let's look here. You ready? Let's look at f of 7. F of 7. Okay. So that's going to be 5 divided by you plug 7 in for x. That's going to be 5 divided by 7 minus 3, 4. Right? So this equals f of x, or f of 7. Right? Now we know these two are inverses. So if we take 5/4 and stick it into the inverse, it should give us our 7 back. So f inverse of 5/4 is what? F inverse is over here. 5 plus 3 times 5/4, all divided by 5/4. Oh, we got us some fractions. All right, one step at a time. Right? Okay. One step at a time. 5 plus 3 times 5/4, 15/4, divided by 5/4. Now I got these 4s in the denominator, right? I'm going to multiply by 4 over 4. 4 over 4. What are they doing out there? All right. Like before, Trevor mentioned, let's treat that top as if it were in parentheses. So you distribute the 4. Okay. So 4 times the 5 is 20. 4 times 15/4, 15. 4 times 5/4, 5. That equals 35/4. Did I say fourths? Fifths? I definitely would have caught that because the next step wouldn't have worked. Which is 7, and that's what we started with. So F inverse undid all the stuff that F did to 7. So F took 7 and added and multiplied, divided, whatever. F inverse takes that number, unmultiplies, undivides, unsquares, whatever, and gives you your original number back in pristine condition. There we go. Questions on that?
I get a question on like the previous one. It just, for me, just my understanding. So F of G means F of G, right?
Yeah, it means you stick G into F. You stick G into F.
Exactly, that's my question. If it's F of G, that means F belongs to G, which should be G, and
yeah.
F is inside the G.
Yeah. That isn't what it means in this case in math. But yeah, I see how that's confusing. And I see how especially it would be confusing. We had this discussion the other night, right? Where it especially be confusing if I were learning that in a different language. I would be confused. And of course, yeah, I told you before, you guys' English is great. It's amazing. Okay. But yeah, it is confusing in that way. But F of G of X means the functional value of G of X. So F of X means the functional value of X. F of 5 means the functional value of 5. You put 5 in for X and it crunches to something. So F of G of X means the functional value of G of X. But Thomas, that is your point is very, very legitimate. One-to-one function. This is an easy concept. In fact, down here, Social Security numbers is the example I just gave you. Different people have different Social Security numbers. Okay? And different Social Security numbers are supposed to go to different people, not the same person. Right? So a one-to-one function, a function is one-to-one if every value in its range is associated with exactly one value in its domain. What does that mean? So you have a function that takes names to Social Security numbers. So that Social Security number is only associated with one person in the domain, not two people. Two people should not have the same Social Security number. Occasionally that's happened without there being any fraud. We actually knew some people who were born the same day. Well, we knew one of the people born the same day in the same year with the same name, the same first, middle, and last name. And they got sent, their birth records got sent, and this is back. The person was born around 1960. They're about, they're antique, right? And they got assigned the same social security numbers. Now, I think some people go through it in their entire life not knowing somebody else has their social security number. But what happened is that this one guy became an accountant, was doing really well in life, responsible. We knew that guy. The other guy who had his social security number, the same name, was in jail a couple times, all this stuff, right? Okay? So what happened, they went to buy a house. He got married around the same time my wife and I did. He went to buy a house, and they said, hey, dude, I'm sorry, Aaron. We ain't lending you money, Okay, right? We weren't going to lend this guy money. This guy owed money everywhere. He had defaulted on car loans, everything. He goes, I didn't buy that car. I've paid all my bills, right? And sure enough, there was another guy with the same social security number. He had to go back to the Social Security Administration, untangle this mess. Took like a year. So he got a new social security number. So guess what happened then? He had a hard time buying a house because he didn't have any credit. He was like, hey, Trevor who? What? You don't exist. You've never bought anything. Get a life, dude. Right. Anyway, see you guys later. Have a good weekend. Have fun. Bye, Kimmy.
Bye.
What's the first thing you're going to do tomorrow? When you're out?
Sleep.
You're going to sleep?
Yeah, I like to sleep.
Outside? What are you going to do? Where are you going to go?
Walmart maybe? I don't know. There's not much to do here.
Not much to do here. Oh my
Really?
Well, don't get into trouble.
That won't.
I do hope you have fun. And I'm sorry you had to go through this.
It's all good.
I've never seen anybody go through the quarantine with a smile like yours. And I really mean that. So keep smiling, girl.
Thank you.
God bless. Have a good weekend.
Have a good weekend.